Okay. I'm going to list the following features of organic compound. One, we're going to be looking at polarity. Okay, let me start with covalent nature first. We'll look at polarity. Covalent nature. So we'll look at polarity. 3, we'll look at solubility. 4, we'll look at reactivity. 5, look at flammability. 6, we look at the thermal low boiling and melting points. Okay, like you know, in the chemistry of bonding, there are two major types of chemical bond. Two major types: primary chemical bond and the secondary chemical bond. We have two major types of primary bonding. Two major types of primary bonding are covalent bonding and ionic bonding. Okay, in that kind of primary bond, all organic compounds are covalently linked or covalently bonded. Let me put it that way. Okay, now you know what happened in covalent bonding and know what happened in ionic bonding. In covalent bonding, electrons are mutually shared between two participating atoms. Okay, it involves the shear states of electron between two participating atoms. This electron can be shared. Okay, can be shared either equally shared or unequally shared. Okay, but basically it involved or it engaged in shared states of electron. So in covalency, since there has been a shared state of electron, a bond is usually denoted to describe the bond shared between two participating atoms. And all covalent compounds are covalently linked together. You look at organic chemistry quite well, very well. That's that the majority of vast compounds of organic compounds are basically hydrocarbons. Okay, you know, hydrogen and carbon, that's what it simply means. And then if you look at that bonding between a carbon, okay, any carbon hydrogen bond, you should know something. This is what you see in hydrocarbons. Okay, or this is also what you see in most non-hydrocarbons. Because in my earlier introduction, I did say that in this same video that carbon is one element that is so excited, so unique. So let's say it can form bond with other elements, or now it's forming bond with hydrogen. Okay, let's start with the bond with carbon. A bond with carbon can form carbon with itself. That's carbonation. It can also form carbon, okay, with other elements like hydrogen. It can form with other elements like nitrogen. It can form with other elements like oxygen. It can form with other elements like halogen, like fluorine, or with chlorine. Okay, these are the things you need to know about uniqueness of carbon. Okay, carbon can form itself. This one is catenation, forming bond with itself. The rest are not catenation. Okay, but once carbon form bond with itself, that's where you can have it as catenation. So what is this bond doing here? This bond simply means that there has been a shared state of electron between these two. Also, of course, you know that the valence of carbon is 4. The valence of carbon is 4. The valence of carbon is 4. That is the outermost shell electron is just 4. And for bonding to occur, carbon is going to use this excited electron for bonding. Okay, this is what hybrid chemistry has done. Okay, for carbon to form bond with other elements, carbon must be in excitation state. There must be an excitation energy that should promote one electron that is paired, okay, to obtain an unpaired electron in an sp3 form of hybridization in carbon. So this is what happened during bonding. So carbon is going to use this excitation electrons in this orbital for bonding. It's going to use this for bonding. This should be used for bonding. This should be used, and this should be used. So in this case of bonding here, before this electron is used for bonding, so there is an incoming electron from other atom. Incoming electron. Let's see, that incoming electron is coming from element like hydrogen. Incoming. So you now see that a bond will always contain 2 electrons. One from this atom, one from this atom. And this electron that has been shared between this atom. Now, this atom that will be here will be an atom that is willing to share just one electron, which most cases could be hydrogen. Hydrogen, and then what? Hydrogen. And now, in this bond, after this chemical bond, the octet states of carbon is achieved. What is the octet state? It's the way there will be a completely filled orbital. 8 orbital. Filled. The octet means that there will be 2 electrons here, one from here, 2, 4, 6, and 8. 8 structure here. And hydrogen also has achieved its own state, but this time it is just 2 states called duplex state configuration. Okay, now, looking at this carbon here, carbon bond, I would like to give you one analysis of electronegativity values of the first 20 elements. Maybe let's show you a little periodic table here. Of 1, 2, 3, 4, 5, 6, 7. Okay, hydrogen here, lithium here, sodium and potassium. Okay, in the same group. Then in group 2 we have beryllium, magnesium, and calcium. In group 3 we have boron, aluminium, and that's it. And here we have carbon, silicon. Here we have nitrogen, oxygen. And here we have, is it oxygen? No, sulfur. You have oxygen and okay, so it's phosphorus, oxygen, sulfur, and fluorine, and chlorine. Okay. So electronegativity here, this is the group. Electronegativity is going to increase across the period. This is given as 2.1, 1.0, 1.5, 2.0, 2.5, 3.0, 3.5, 4.0. Okay, go down, it decreases. So sodium is 0.9, 0.8. But going across is increasing. So here is 1.2, 1.5, 1.8, 2.1, 2.5, 3.0. And here is 0.1. Sorry, 1.0. 1.0. Okay. So my main interest here is carbon here. Carbon and hydrogen. Okay. Or carbon and carbon. Carbon here, this carbon is 2.5, this carbon is 2.5. So difference in the electronegativity of this particular carbon is 0. Now, for a bond to be covalent, or for a molecule, a compound to be covalently linked together, or for it to be a covalent bond, the electronegativity difference between the participating atom must at least be 2.0 or above. 2.0 or above. So what the difference in the electronegativity value is 2.0 or above. The bond is covalent. So what is the difference in the value of these two carbon? Is 0. So it's not up to 2.0. What is the electronegativity difference between carbon and hydrogen here? This is 2.1. This is 2.5. I think it's less than 0.2. Sorry, I think it's less than 2.0. And so this bond is what? Covalent. Then, what is the difference between this carbon? All these carbon here, all of them are 2.5, 2.5, 2.5, 2.5. So plug the values from this table here. 2.5, this is 3.0, this is 3.5, this is 4.0, this is 3.0. So there won't be any difference up to 2.0 in this case. So all these bonds, all carbon-hydrogen bond, carbon-nitrogen bond, carbon-oxygen bond, carbon-fluorine bond, carbon-chlorine bond are all covalently linked. Are all covalent bonds. So most organic compounds like this are all covalently linked. For a bond to be ionic, the difference in their electronegativity between the two participating atoms are like, for instance, I have sodium and chlorine. Okay, there won't be bond here. But I should know that this will give you sodium chloride. What is this compound? Is it ionic or covalent? To know whether it's ionic or covalent, so let's see the difference is here. Sodium here is 0.9. Chlorine here is 3.0. So difference in the electronegativity value is 2.1. Is 2.0. Is 2.0. So the value for each to be covalent, the difference in their electronegativity should be less than 2.0. But if it's above 2.0 or 2.0 or above, the bonding is ionic. So this is ionic. All organic compounds are covalently linked. That is their nature. They are all covalently bonded because of proximity, closeness in their electronegativity. That is why they are all covalently linked. So the bond that is existing between atoms of organic molecules, covalent bond. We'll look at polarity quickly. That was the time because it's exactly the same thing said here. Polarity of bond. Okay, in terms of polar, there are some bonds here in this example that are polar, while some are not polar. Okay, to explain polarity here, polarity happens if there is a distortion or if there is an unequal share of electron between two participating atoms. If there is an unequal share of electron between two participating atoms, or if the electronegativity difference between the participating atom is, if it is less than 0.5, if the electronegativity difference between two participating atoms is less than 0.5, the bond is said to be non-polar. The bond existing between these two carbons is non-polar. This bond is non-polar. Why? 2.5 to have the difference here, 2.5 minus 2.5 will give you 0.0. And the rule says that if it is at least above 0.5, above 0.5 the bond is polar, but less than 0.5 the bond is non polar. Alright, here. Less than 0.5 electronegative difference. Less than 0.5 electronegative difference. Bond is non-polar. But above 0.5 electronegative difference, bond is polar. So this is non-polar. Let's check this. 2.5 of carbon minus 2.1. Difference is 0.4. So this bond that is linking carbon to hydrogen bond is also non-polar as well. Let's check the second one. Check it is exactly 0.5. So the bond holding this carbon and hydrogen is what? Is polar. This one is polar. So carbon oxygen bond is polar. Carbon oxygen bond is also polar. And then what? Polar. So out of 1, 2, 3, 4, 5, 6 here, 2 is basically non-polar, and the rest are polar. So that's one thing to know about polar. And then in that polarity as well, look at this. Suppose that I have a case where I have H bond Cl. Okay, what is this bond here? This bond, of course, is polar. Checking the electronegativity difference, it should be above 0.5, so it's polar. So what means that this bond is polar in the sense that when removing, remember that there's a bond here is occupying, having 2 electrons. That is 1 electron from this other atom, the other from the atom. So if I want to take, there will be a bond cleavage. Yes, cleavage of bond, removal of this bond now. Where will the 2 electrons in the bond go to? I remember already that the valency, the number of electrons in the atom of chlorine is 7. 1, 2, 3, 4, 5, 6. Where is the 7th one? Is the Zyne bond. Hydrogen also only has a 1 bond. It's already in that 1 electron. It's already in that bond. So what happens if I take out or remove this bond or cleave this bond? What happens to the electron in that bond? All the 2 electrons in the bond will go to the atom with more electronegative value, and which is chlorine. So the 2 electrons all go to chlorine. So in this case, there is an unequal share of electron in the bond. So one take it all. In the case where one element take all the electrons all, and that's going to make hydrogen here partially positive. and then chlorine that has accepted that electron is going to be partially negative. So in this case, a dipole moment is achieved. Or you can answer that this particular bond is what? Is polarized, or it's polar, where there will be an unequal share of electron, or a distortion of charge, which is positive and what? Negative. But in the case where we'll have a carbon atom and maybe another carbon atom, okay, and there's a bond here existing, and I want to know if this bond is polar, okay, what happens if I tend to take away this bond? Okay, it means that since these two are the same elements, being that they will all have the same electronegative difference, or they will now share the electrons they have in the bond equally. So once there is an equal share of electron in a bond, in a particular chemical bond, once an electron in the bond is shared, please, the bond having shared the electron here will not make this particular compound polarize. I'll give you an instance of hydrogen, H and H. And then what happens if I take away this bond? One electron goes to this H, one goes to this H. What do you have here? How about H plus H? It doesn't make it polarize, doesn't make it positive and negative, it doesn't make that. But in this case, I'll have H plus Cl, because this chlorine will accept 2 electrons. Okay? This particular hydrogen will give out electrons to become positively charged, and the other one becomes what? Negatively charged. So it means in this case that H is going to be partially positive in that particular compound, while N trying to pull this electron to itself. So the electron will be distorted, the electron will be towards chlorine. Electron will be dragged. The electron will not be dragged towards chlorine than hydrogen. But if electron is dragged between 2 of them equally, maybe in the case where you have a bond separating 2 atoms, and the 2 atoms have the same, almost the same electronegative value, and if the electrons are now shared to 2 of this atom, the 2 are dragging at the same time, or equally sharing this electron in the bond is not going to be polar. Rather, the bond will be not polar. But in the case where one particular atom is now trying to possess all the electrons towards itself, trying to make the one that is on the other side, not receiving the electron, partially positive, and the one that is putting the electron to itself, partially negative. In that situation, the bond existing between these 2 atoms will be polarized. A molecule of such nature are polar substance. And since they are polar, these substances are soluble in water. And that will take me to solubility. What is solubility? Most organic compounds that are non-polar, like hydrocarbons, any compound that is carbon hydrogen, like I showed you, this bond is non-polar. Halo hydrocarbons like alkanes, hydrocarbons, alkene, hydrocarbons, benzene, hydrocarbons, alkyne, hydrocarbons. So since the main element in that compound is carbon and hydrogen, and carbon-hydrogen bond is a non-polar bond. So this is a non-polar bond. It means that the molecules are non-polar. And it means that these non-polar molecules will be insoluble in a polar solvent, like water. Water is a polar solvent. All bond in water is polar bond, polar hydrogen bond. H2O. Check it. OH. OH. Water. OH. This bond is polar. Check its polarity. Oxygen here being more electronegative here, 3.5 against 2.1. We tend to what? Get attracted to electron than hydrogen. Then making this partially positive, making this partially what? Negative. Look at what it means now. It means that this side of the pole is partially negative, this is partially what? Positive. This bond is polar. And since it is polar, it's a solvent. Remember, it's a solvent. And since it's a solvent, it will dissolve all polar organic molecules. There are some organic molecules that are polar. Organic molecules in which their main element are not only carbon and hydrogen, but some of them they may have some kind of other elements that the electronegativity value is far, far beyond that of carbon. Should be polar. Example, I'll give you an example like ethanol. Ethanol is a polar organic compound, but ethane is not polar. The reason why ethanol is polar is because of the hydrogen bond that is existing in the functional group. Now, if you look at ethanol. Ethanol. See? Okay, this is ethanol. This is ethene. Okay, both are organic compounds. Okay, both are organic compounds. But like you know, that there's one bond here that is very important in this ethanol, which is this bond. This is a polar bond. And this is a non-polar bond. A non-polar bond. Okay. And here is H2O. Here is H2O. Here is H2O. Also, these two bonds here are also polar bond. Okay, so ethanol and ethane, because of polar bond existing between oxygen and hydrogen, and also between carbon and oxygen here, but the mainstream here is this particular bond here. This bond here is polar bond, and this makes this ethanol a polar organic compound. And then ethane having only carbon hydrogen bond all through. So all the carbon hydrogen bond here are all non-polar. Okay. Then in terms of solubility, ethanol having polar bond will be soluble in water. But ethane with non-polar bond will be insoluble in water or will not dissolve. This one will be miscible with water. This will be immiscible with water. Reason because polar solvents or polar molecules dissolve polar. A polar solvent can only dissolve a polar molecule. Non-polar dissolve non-polar. Like you know, likes dissolves like. So a polar will dissolve polar, a non-polar will dissolve non-polar. So ethanol is soluble in water. In water, this particular hydrogen will form an intermolecular force. The hydroxy group and the functional group of ethanol will form a hydrogen bond with water. And that's why this will be miscible. But will not form such. There won't be such here. So there is no intermolecular force possible between ethane and what? Water. So ethane is insoluble. But ethane will be soluble in benzene. Ethane will be soluble in benzene or soluble in tetrachloromethane. Also a powerful non-polar solvent. So this is an issue of solubility. So some organic compounds are soluble. Those organic compounds that are soluble will have polar bonds. Example, alcohols, alcanals, alkanoic acid, alkanones, amides. These organic compounds that are soluble because of their functional group. So other organic compounds that are insoluble in water are basically hydrocarbons, are all insoluble in water. Hydrocarbons like alkanes, having only carbon and hydrogen bonds, so they are not polar, so they can be soluble in water. Alkanes, alkynes, and benzene. So these are insoluble in water. So in terms of solubility, some are soluble, some are insoluble. Basically, all hydrocarbons are insoluble. Reactivity, of course, reaction in organic compounds are very too slow. In fact, some of the reactions are non-spontaneous. What can only be spontaneous at high temperature or use of catalysts. Some reactions are slow. So organic compounds are one reaction. The reactions in organic chemistry or reactions in organic compounds are very slow. Because of these bonds present in organic molecules. And during chemical reaction, these bonds need to be broken. Some of them are pi bonds, some of them are sigma bond. Those that have sigma bond, like this one you're seeing here, are much more stronger than a pi bond. So for reaction to occur, atoms in a molecule needs to effectively collide with one another. And for that collision to be effective, these bonds need to be broken. And the energy must be absorbed to break bonds. And because of that bond breaking, so it takes, their reactions are gradual before reaching into a completion because of the bonds that are present. So they are not in ionic states most often. So most of reactions that are in ionic states basically are instantaneous. But reactions here are not instantaneous. It is slow. And some of these reactions occur in the presence of light. That is, they need high temperature to occur. Some reactions occur when you employ catalysts to show that their reactions are very slow because of the chemical bonds they possess. And for these reactions to occur, bonds need to be broken endothermically. So that's why reactions takes time. Inflammability, okay, they are flammable. They are highly flammable. Okay, that flammability is an occurrence of being. Flammability is a type of a reaction whereby most of these organic compounds, in the presence of air or oxygen, they can what? Burn. They can burn. They can easily combust in the presence of oxygen. An example of organic compounds that are highly flammable is that of hydrocarbons like fuel and wood. When you burn them, they exothermically burn to give you carbon dioxide, water, and large amounts of heat. Exothermically, that's how they burn. Thermal instability. They are thermally unstable. Organic compounds are thermally unstable. As little heats, they will basically decompose to give you other instantaneous product. You can see fuel being, that's why cracking process is very important in organic, because it is achieved in organic compound. Cracking is a process of using heat or catalysts to break down this organic compound because of their unstability. That's why they are thermally unstable. Boiling points and melting point. Basically, organic compounds have low melting and boiling point because of nature of chemical bond. Chemical bond is basically covalent. So covalent bond have low melting generally and low melting point. So these are the properties or these features or characteristics, property of organic compound: covalent nature, polarity, solubility, some soluble, some insoluble, reactivity, slow in reaction, flammability, highly flammable, thermal stability, unstable. They can easily be easily be broken down on heating. So low melting and boiling points. These are the properties of an organic compound. So quickly, we're going to be looking at a functional group shortly.